Eva Savolainen, and this is Introduction to Research Data Management. I will start sharing. Okay, now I hope you can see my slides. Okay, let's start with the outline of today's session. First, we will cover some definitions and reasons why RDM is important. Then we will look briefly at the requirements from funders and publishers. After that, we will proceed to research data management lifecycle and go through different steps of RDM, concentrating on best practices and services Aalto provides to support them. Let's start with definitions. There are many ways to define research data and research data management. To put it short, research data is any information that has been collected, observed, generated, or created to validate research findings, whereas research data management refers to the organization, storage, sharing, and preservation of this research data. There's nothing mystical about research data management. It's simply good scientific practice. Research data can take many forms. It can be either textual, visual, numeric. It can be interview and survey data, text documents, photographs, films, drawings, measurement data, sensor data, codes, algorithms, software, and so on and so forth. Research data management practices always depend on how the data will be generated and what analyzing methods will be used. And also instruments and software define your data management practices. Research data can again be divided to three categories: personal data, confidential data, and public data. If there is personal or confidential data or both involved in your research, you must consider special data collecting and handling practices. These requirements result from ethical guidelines and from the legislation. For example, before you start collecting personal data, you must inform the participants according to the EU's Data Protection Act. And when your data is obtained from a company and covers trade secrets, you must store the data so that you can limit access to the data. Now, why research data management is important? Firstly, by managing your research data well, you will save time. It will help you and your colleagues to find, understand, and communicate about the data. It also improves transparency and possibilities to verify and reproduce the research results, and enables reuse, sharing, and opening data. Finally, nowadays research data management knowledge and skills are required in research and also in companies. It's also notable that our main funders and university take open science very seriously, and they have set several requirements regarding it. For example, they want you to write a data management plan that shows that you can manage your data properly. Also, you should be prepared to publish your data if there are no valid reasons to keep them closed. Nowadays, a growing number of journals also demand open data. But you are not alone in this. Our university services help you to meet these requirements. Aalto guidelines and data management experts are here to help you with all demands related to research data management. If you are not familiar with our policy and guidelines yet, we warmly recommend you to look at them. Aalto Open Science and Research Policy was just recently updated, and we have the link to it here on the slide. Now let's turn to data management on practical level. This picture covers 7 topics that are crucial parts of the research data management lifecycle. These are basic steps of research data management, and they are interlinked with each other and often executed parallelly, not necessarily exactly in this order. First, before your project starts, it's important to plan how you will manage your data. Second, Typically, the legal and ethical issues should be considered also before you start collecting. The third topic covers and practices related to organizing and documenting the data. The fourth is about storage and sharing the data. The fifth practice, publishing the data, is relevant if there are no, for example, ethical or contractual reasons that prevent opening the data. Typically, the final step is reporting the data in ACRI's research information system. The final step here, long-term archiving, is relevant only in few cases. First, about the planning. Data management plan is a practical and rather short document. It is a kind of collection of management practices you plan to apply during the research. It describes what kind of data you will collect or generate and how you will handle and manage it. The DMP should be written alongside with the research plan before generating or collecting the data. You should pay special attention to the legal and ethical issues if you will use or generate personal data or obtain data from external sources or aim at inventions or patents. The reasons to write a data management plan are quite simple and practical. The plan helps you to be systematic in managing your data, and hence it will save your time. Moreover, many funders require plans. They may have special requirements regarding the DMP, so it's good to check their guidelines in advance. On the left side, you can see an outline of questions a data management plan should answer, starting from description of data and ending with your possible opening plans. Please remember that DMP is a live document that should be updated during the research process. On the right side, there are some tips from where you can find help for writing a DMP. DMP Tuuli data management planning tool contains both funders and general DMP templates. At aalto.fi, there are guidelines for writing a DMP, and you can also find some example DMPs there. And remember also our DMP review service. You can send your DMP to researchdata@aalto.fi and receive comments. Next, we will move to ethical and legal issues. And again, by following the Aalto guidelines, you will meet the ethical and legal requirements. Handling of personal data page gives instructions on, for example, how you can inform your research participants. There is also another page related to personal data and ethics. And whenever in doubt, you can contact the lawyers and other experts for guidance. Finnish Social Science Data Archive provides also good guidelines, for example, tips on anonymization. Managing personal data can be divided into 3 categories according to the phase of research. Before you start collecting data, you should plan the life cycle of personal data handling. If you will collect sensitive personal data, you should get an ethical pre-review. And the most important thing is to sort out the procedure you should use to inform research participants about their rights. When you collect, store, and share your data, you should use secure online data collection methods and services that suit to the personal data and enable defining who has the right to access the data. And finally, when you publish your data, you should make sure that you can actually publish it. Prepare your data for publishing by using anonymizing methods if needed, and define access rights in the repository. If you cannot publish the data, you can still publish the description of the data in most of the cases. Here we have some useful links related to ethics and legal issues. There is a link to GDPR, the EU's General Data Protection Regulation, all European Academy's Code of Conduct, and recommendations by the Finnish National Board on Research Integrity. Next, we will take a look at organizing and documenting the data. The reasons for organizing and documenting are quite simple. If data is not organized and documented, it might happen that you won't understand your data after 5 years, even yourself. And your group leader mightn't understand it without documentation, even today. Without proper documentation, it's quite likely that no one will be able to continue the project in the future. So the overall aim of organizing and documenting the data is to ensure that you and others can find, use, and cite your data. Moreover, good documentation also decreases the risk of false interpretations of your data. Here we have some tips for organizing. Firstly, it's good to develop a logical directory or folder structure. You should name folders appropriately, separate ongoing completed work from each other, and schedule the time when you clean the unnecessary files from folders. Consistent file naming helps you and your co-workers to find the data efficiently. In addition to meaningful names, it's good to agree on elements used and which elements should be first with other members of your research group. And on top of these practices, a supplementary document such as a README file that describes the naming and structures of folders and file facilitates both file finding and data reusability. On the right, you can see an example by Michael Kukling, who is a researcher at Aalto. In the folder structure above, manuscripts, process data, raw data, and reports have been divided into their own subfolders. Files are named consistently, and there is also a README file that explains the structure and naming conventions. So the idea of documenting the data is to help others to interpret the data correctly. Documenting is data specific and depends on, for example, your methods or the software you use. Therefore, it's quite difficult to give guidelines that fits everyone. However, the main idea is that good documentation enables using data independently without contacting the creator of the data. There are 3 approaches to documenting. Firstly, information, or to use another term, metadata, can be included within data files. In the example, you can see variable names embedded in a spreadsheet. This kind of embedded information can also be descriptive headers or summaries, or descriptive information at the beginning of interviews. Secondly, you can use an additional document to describe the data. Common ways to do this are codebooks or README files. Thirdly, in some fields, you can just add your metadata to a database of the repository by using the metadata standard of the aforementioned repository. You will need knowledge on metadata standards anyway if you are going to deposit your data later to a repository. On basic level, metadata means bibliographic information similar to, for example, articles such as title, creators, and so on and so forth. There are fields which have discipline-specific metadata standards, such as DDI, that is aimed especially for social sciences. Finnish Social Sciences Data Archive uses DDI. When you deposit your data there, you don't need to be a master of DDI and know everything about it. They ask you to fill in the form, and the metadata you provide will be stored in DDI format, although you weren't really aware of the standard. However, it's good to be aware of the metadata requirements of the archive you intend to use. General standards are standards that are commonly used in various databases, such as Dublin Core. And there are links where you can find more information on these standards. This README file example here covers general information like authors and description, but it also includes information about methods, protocols, and other important data-specific information. The content of a README file is always data and project specific. Next, about storage and sharing the data. The storage solutions are provided by Aalto IT. You are probably using your personal storage space already, the home directory. But for data, the other two options, the department storage space and the research group storage space, are preferable because they allow collaboration and sharing the data within the department. The reason why you should use these network drives is that you can count on that these drives are secure, backed up, and easy to reach from everywhere, and access rights can be defined by person. Network drives are also suitable for personal and confidential data. For storage and sharing, you can also use Aalto Cloud Services. There are many of them. They are very easy to use, but please remember that only eDuuni is suitable for personal and confidential data. For example, interview data containing personal and sensitive information or confidential data obtained from a company cannot be stored and shared via cloud services. More information about these services and also about the security level of these storage solutions you can find at aalto.fi. Now let's turn to data publishing. Data is considered open when it's stored and published in the data repository. The main idea is that in the repositories, data are available to anyone to find and reuse. As a researcher, you have the final control of how open your data will be in the repository. Is it open to all, embargoed until after publishing the results, or open only by request? Making the data open is highly recommended. Published data can be reused, and only published data can be considered as an independent research output. Published data can be cited, and it will thus give credit to the contributors. And your article also gets more citations if you link open data to it. And as mentioned before, funders often require opening data, and some journals also do the same. There are general repositories that cover different types of data and research outputs, such as Zenodo or EUDAT. FAIR data services are national services to store, describe, and publish data. The domain-specific repositories are planned for the specific data types, for example, Cambridge Repository for crystallographic data, or the Finnish Social Science Data Archive for social sciences and humanities. re3data.org is a catalog of repositories where you can search for repositories, for example, according to their domain. Here we have links to datasets that have been published by other researchers from different schools. Typically, the data management process ends with reporting your data in ACRIS, the Research Information System of Aalto. You can just send the link to your published data to researchdata@aalto.fi, and the information about your data will be added to ACRIS. If your data contains personal or confidential information and cannot be published, you should register the metadata of your dataset to ACRIS anyway. For example, Academy of Finland demands that at least the metadata of data should be published. This is also a very important step because reporting ensures that your data can be identified like your articles. It will increase your visibility because information is openly available in Aalto's public research portal. You can also include the data to your CV, and in addition, the data can also be linked to other related output in ACRIS, such as articles and projects. The last topic is archiving. In practice, this is relevant only in very rare cases. Namely, the archiving here means long-term preservation of highly valued data. The archived data will be selected according to its scientific or historical value or uniqueness. In Finland, we have one provider for long-term preservation of research data, and that is CSC FAIR Data Service. And finally, here we have collected links to some useful resources. All the research data management pages contain guidelines and other materials. On RDM training page, you can find recordings of previous webinars as well as information on other autumn webinars. Data support network can be reached in research data at aalto.fi. Data agents, who are researchers specialized in research data in departments and schools, can give you hands-on support on your questions. And personal consultations are also available by request. Thank you for your attention. And now, if there are questions, we can turn off the recording and start the discussion.